Dear students, in this video, we are going to discuss the phenomena of mutual induction. I hope you all have seen my video on self-induction, and I hope that it was clear to you. In case if you don't know what is self-induction, then you need to see that video first to understand mutual induction. See, all of these topics are simply based upon Faraday's laws on electromagnetism. That whenever a changing magnetic flux is there, then the EMF is induced in a coil, and due to it, what exactly happens? A current is induced. So let's try to understand what is mutual induction. Mutual induction is the property of two coils because of which one coil opposes any change in the strength of the current flowing through the other coil by developing an opposing EMF. Okay, let's try to visualize this situation. First of all, I'll give you a very brief introduction about self-induction. If you remember it, I told you that if this is some coil, this is a solenoid which is connected to two terminals of battery, and then there was one key. Okay, K. When this key K was pressed, what exactly happened? The current started flowing in the circuit, and the current flowed. When the I increased, B also increased, where B stands for magnetic field. We know that solenoid has a magnetic field equal to mu naught Ni. So current जब increase होगा तो magnetic field भी increase होगी, due to which flux will also be increased because flux is Ba cos theta. Now what did you see? That flux changed from 0 to some value, right? Flux changed from 0 to some value, because of which what happened? An EMF was induced. That EMF induced in such a direction so that it can oppose its own cause. और इसका cause क्या था? देखो, अगर आप की प्रेस ना करते तो करंट फ्लो नहीं करता, करंट फ्लो नहीं करता तो मैग्नेटिक फील्ड डेवलप नहीं होता, अगर मैग्नेटिक फील्ड डेवलप नहीं होता तो फ्लक्स डेवलप नहीं होता. सो फ्लक्स is increasing, and the cause of this increase in flux is the growing current in this solenoid. So basically current is the cause, na? So now you need to understand that EMF will be induced in this coil. That EMF will be known as back EMF, induced EMF. That EMF will be induced in such a way so that it can oppose its own cause. So that it can oppose its own cause, which is current. So that was self-induction. Self-induction was a property of one coil, where one coil induced an EMF in itself such that it can oppose the growing current in it. Okay? So, but now we have mutual induction. As the name suggests, mutual. So what does it mean? You have right now got two coils. So suppose this is one coil which is connected to the battery and key K. Okay? Suppose this coil has a name P. Now you have another coil, and another coil is such that it's not connected to a battery. It's simply kept near the first coil, and this coil is connected to a galvanometer, right? It is simply connected to a galvanometer. I hope it's clear. Now what exactly will happen? When you will press this key, current will start flowing. And when current will start flowing, it will generate magnetic field inside this coil. See, when the key K is pressed, current starts flowing, right? And because of this current, magnetic field also starts the developing. Magnetic field also starts developing, and because of which there will be magnetic field lines. But those magnetic field lines are closed concentric loops. ओके, सो एग्जैक्टली पता क्या होगा, क्योंकि आपने इस कॉइल को बहुत पास में रखा है इसके. सो व्हाट एग्जैक्टली विल हैपन, दिस coil will also experience magnetic field lines. Some of them will also pass through this coil. So this coil was earlier having no magnetic field lines when the key K was not pressed. Okay, when key was not pressed, there was no current in this coil, and hence no magnetic field lines, and hence no magnetic field lines were entering in the surroundings also. और सराउंडिंग्स में तो यही पड़ी हुई है कॉइल. सो अब यहाँ पे कोई फ्लक्स नहीं था पहले. बट नाउ ऑल ऑफ अ सडन व्हेन यू हैव प्रेस्ड दिस की, so that magnetic field lines are there, so some of them will pass through this coil also, na? And eventually they'll change the magnetic flux. Eventually what exactly is going to happen, flux will be changed, and most importantly, when the flux changes in this coil, then this coil will start showing deflection in galvanometer. देखो आपने इसमें एक्चुअली में कोई बैटरी कनेक्ट नहीं किया था, and according to that no current should flow in this coil. But it is very amazing that the coil which is nearer to it, when the current starts flowing through this coil, the current also starts flowing through this coil. Can you imagine? So this means what exactly is happening? The current flows in this coil in the opposite direction to this current, because it is trying to oppose its own cause. Okay, it's trying to oppose its own cause. So that's how this is known as mutual induction, because it has induced current in itself to oppose the current flowing here, and that's why it's known as mutual induction. Okay, so after that you should know that if more the current flows through this, देखो आपने ज़्यादा वोल्टेज की बैटरी लगा दी, so that more current will flow through this coil, more magnetic field will be there, because B is equal to mu naught Ni. So, and when more magnetic field will be there, more magnetic flux will be there, because phi is equal to BA cos theta. So what are you getting from it? That overall flux at last will be directly proportional to the current flowing. So same way, phi is directly proportional to the current flowing. अब जितना ज़्यादा इसमें करंट फ्लो करेगा उतना ज़्यादा मैग्नेटिक फ्लक्स में चेंज होगा और उतना ही बैक ईएमएफ प्रोड्यूस होगा दूसरे कॉइल में. सो phi is equal to mi, where m is the constant of proportionality, and this is known as coefficient of mutual induction. This is known as coefficient of mutual induction, and it has another name also, which is known as mutual inductance. Right? I hope it's clear. So now when you want to define this m, suppose current is 1. So phi is equal to m into 1. So m is equal to phi. So mutual induction is nothing but it is equal to magnetic flux only when the current flowing through the coil is unity. Okay? So after that, you have E is equal to minus d phi by dt. So E is equal to minus d by dt, mi, because phi has the value mi. So m common, d by dt, I. So di by dt, when it is 1, so m will come out to be equal to minus c. M will come out to be equal to minus c. So mutual induction is also defined as the EMF induced in the second coil when the rate of change of current through the first coil is unity, when di by dt is unity. So this is one of the definitions of M. Remember, M also has the same unit, Henry. Just like self-induction, it also has the same unit, Henry. But the major point is, can you see the situation is very different right now? You have two coils when you talk about mutual induction. You have only one coil when you talk about self-induction. Now, coefficient of mutual induction M. Can you tell on what factors will it depend? So, point number one, whatever is the distance between the coils, that's going to influence largely the value of M. देखो, अगर डिस्टेंस आप ज़्यादा कर देते हो तो ऐसा भी हो सकता है कि जो फ्लक्स इसमें डेवलप हो रहा है वो उसमें जाए ही ना, right? So whatever is the distance between these two coils, that will largely influence the mutual induction. Next is how you have placed the coils, whether this is here, where it is. So the position also exactly determines the coefficient of mutual induction. And last but not the least is size of coils, shape, number of turns, like पूरा ज्योमेट्री उनका क्या है. इन सभी फैक्टर्स से ये इन्फ्लुएंस होगा कि कितना बैक ईएमएफ इसमें प्रोड्यूस हो रहा है. Okay, I'll just quickly recap the phenomena for you. The phenomena is known as mutual induction. Okay, so what exactly happens? You have one coil which is connected to a battery and to a key. And there is another coil which is not connected to the battery and it is also not connected to a key. It's simply connected to a galvanometer. Okay? So after that, when this key K is pressed, the current starts flowing through the coil. When the current starts flowing through the coil, magnetic field is induced in the coil. When magnetic field is induced in the coil, its flux, the number of magnetic field lines, they go on changing. When they go on changing, what exactly is going to happen? The few of the magnetic field lines will also pass through this coil, which is a neighboring coil. And what happens, since it's a neighboring coil which is not connected to a battery and all of a sudden its flux is changed, it will try to oppose that change in flux. Okay, and EMF will be induced in it and it will try to oppose, EMF will try to oppose the change in flux. अब change in flux का कारण तो था यहाँ पे flow करता हुआ current, उसी की वजह से ये सारा story begin हुआ. So ये उसी current के opposite direction में अपने अंदर current flow करवा लेगा इस direction में. देखो, यहाँ करंट पॉजिटिव टू नेगेटिव ऐसे फ्लो कर रहा था, यहाँ करंट गैल्वेनोमीटर की डिफ्लेक्शन इधर क्यों है? क्योंकि करंट ऐसे फ्लो करेगा, क्योंकि उसी करंट को अपोज करेगा. सो ये सारा फिनोमिना जो है, दिस इज नोन एज म्यूचुअल इंडक्शन. थैंक यू.